So, JavaScript 4. We're recording good. Okay. So, this lecture is about animation and game design. So, we might fairly ask, well, this is silly, right? This is not, University of Illinois School of Computer-Aided Game Design. Yeah, it's not that, right? So, why are we doing this? Well, number one, people like animation, people like games, right? If you want to get people to your website, sometimes you need to provide something a little bit flashy for them. So, this sort of thing, it's a good way to attract, retain site traffic. In fact, it occurred to me that teaching people enough JavaScript that they could put some of these little games on their own websites would be a really good way to draw more traffic in when I teach my graduate web analytics course. And it starts in a couple weeks. We've always had a problem where people set up their websites and then they have a lot of trouble getting anybody to show up. But I suppose if you put up some games and you track high scores and stuff like that, you'll at least get, maybe a couple hundred visits. So there's that. Number two, and more relevant for us, they're a fairly painless way to learn more advanced JavaScript techniques. Okay, so all the stuff that we do when we design games, a lot of that is portable to other applications, to non-game applications. If you're setting up an array, manipulating data, the array structure doesn't care what you're doing with it, right? So whether it's something online retailing or, keeping slugs from taking over the world, yeah, either way, the mechanics of it are pretty much the same. And of course, got to mention, you might win the apps lottery, right? Maybe you design some kind of simple, fun game that people go nuts for. Tetris is an excellent example of that. Now, as it happened, the dude who designed Tetris, for a long time, it was in the old Soviet Union, and it was, basically some kind of corporate development there. So he couldn't really personally make any money off of it. But as time went on, yeah, eventually he did get some cash from that. I looked up his net worth. He's apparently worth a few million now. So something like that is possible. Yeah. Okay. So questions you might ask, how much money can you earn from an app? Well, if you come up with something popular, you might get a few thousand a day, but probably not going to get anything that popular, but you never know. So like I said, it's kind of like winning the lottery. Other stuff, if you're interested in JavaScript development of these kind of apps, there are frameworks for doing that. I don't know too much about it. This isn't really my thing, but React Native is one. So you can basically code up your app in JavaScript and then, let people deploy it to their smartphones. So, or install it on their smartphones. Okay, so there's a few of them out there. I have some other links later on. If you're interested in this sort of thing, by all means, do check into it. Okay, because the more games you design, the more you'll get better at doing it, and the more fun, the more fun they will be, and thus maybe the more money you'll get. You can get people to try them out. Okay. So first we'll start with animation. Now animation is basically just switching between images at regular intervals, right? So you have one or more images, you switch between them, and it looks like something's moving, right? This is the same old thing from moving pictures back in the day. Or if you ever have done flip books where you like flip through the pages and the image changes, yeah, that's exactly it. Now, if your images are, being switched very quickly, they can actually appear smooth, right? You won't notice what's going on. But of course, if you have a whole lot of stuff going on in your window, if it's a really busy thing, and if you're doing some complex images, complex effects, things like shadows, haze, lighting effects, those things tend to require a lot of CPU cycles, and that can really bring down your frame rate. So I'm sure you've all experienced it. You're in some game and it gets really busy, and what used to be like very smooth flowing just becomes really, clunky start and stop. Yeah, it doesn't feel as good. So that's what animation is, switching back and forth between images. If you do it at a manageable level, it looks good, but if you can easily overload your machine. So we're going to check into 3 basic techniques. Number 1, image flipping. Number 2, DOM animation. So that's, our document object model tree. We can alter that. And then the last one, redrawing canvas portions. So that's what we've seen lately. So image flipping, right? Image flipping, there's one way you can do it, right? Very simply, grab some static images and you can display them without constructing them, without redrawing them. Okay, so for For example, we have our old W3 schools here. This is a light bulb. Okay, if we see here, there are two images. Okay, so here's our image tag over here, which corresponds to this light bulb. And there are two images that it could be the source. So SRC is the image source. So as long as it's in the same folder as this HTML document, it can grab it right there. And here is our other one, our bulb off. Okay, so the initial source is bulb off. Okay, it's going to read, yeah, find this one, bulb off. And then what's going to happen? This one's going to flip to the other one. So we have two buttons. This one says turn on the light, and it's going to flip it to the bulb on GIF. This one says turn off the light. It's going to flip it to the bulb off GIF. So turn on, turn off, turn on, turn off, turn on, turn off. Now, of course, what's happening, right? These images are the same, except for this interior is colored yellow. So that's all we see. It's a very simple animation. And yeah, ta-da. Okay, now, of course, if you're doing other stuff in games, you know, the basic process that's going to happen, let me drop into Paint here, is going to be something more like this. I don't know. I'm going to try to do something in here. It's going to be something like this. You have, you know, you have a few images, and they're all going to be slightly different, right? Maybe something's going to be moving across the sky. I don't know. So let's do, this can be like a couple pixels over. Okay, and then this one could be a couple pixels over, even more, and so on, right? And the net effect will be that the stuff moves. Problem is, as you can see, is if you want to do very smooth animation and your images are high resolution, storing all of these images is going to, whoop, damn it. Storing all these images is going to require a lot of data space. You don't really want to do this, okay, for a large set of images. Now, of course, sometimes you do. So if you have some image of some dude running along and you want to show that animation fairly smooth, yeah, you have to keep at least the bitmaps of that little guy, store them in some sort of compressed format, and download all of them when you begin your game. Okay, but if you do this all the time for all your stuff, yeah, the amount of memory involved can be very, very large. So that's one of the things when you install a new game and you see that it's unpacking like untold gigs of data, that's usually this sort of thing that's being unpacked, all these image files. Okay. So again, downside, the images, if you're doing image flipping, they have to be predefined, can take up a lot of money. So a lot of memory. So what you maybe don't want to do is have, you know, many gigs of data involved, and somebody comes to your website and they want to play this game. Well, guess what? It takes like 3 minutes to download all the stuff to be able to play. Most people aren't going to have that much patience. Okay. The other thing is this kind of code, it limits your dynamic image options. So if you're relying entirely on predefined images, yeah, you basically can only go with what's there. It doesn't always allow you much flexibility. So, second one, DOM animation. This is kind of neat. So I'm just going to show you what it is first, and then we'll talk about it a little bit. Okay, so here's our example. Try it yourself, okay? So first, JavaScript animation. So what we have here, a style tag with two things. There's a container and there's an animate. Okay, the container is this 400 by 400 box. It's in yellow. The animate is this other box, 50 by 50, and it's in red. Now it's kind of neat. We'll see what happens here. I'm just going to press the button and run it. Boy, what's going on here? Oh, I must have grabbed the wrong thing. Yeah, I grabbed the wrong thing. Haha. Okay. So this, has a click me button. So we'll run this. Okay, great. So when I do click me, you'll see it falls. That's kind of neat. Okay, I mean, the fact that the square moves is not that exciting, but here's the thing. How does it work? Well, if you press the button, right, it does this my move. Well, let's see what's in my move. Okay, it's going to find this animate, right? That's this red square. Initially, the position is 0. It's going to set a timer. Okay, so the function it's going to call is frame. It's going to call it every 5 milliseconds. And here's that function frame. Okay, well, let's see what goes on in there. Well, if it reaches the bottom, if the position is 350, it goes all the way down there, right? Because remember, this is 400 by 400, so this upper left corner is at coordinate 350. Then it clears the interval. It stops the timer. Otherwise, it increments the position by 1, okay, and then creates the new element style. So in whatever pos.px, so its position is going to be up here, right? We're going to set its position because this thing is absolute. So its position attribute, that's what the top is going to be. And the left attribute, that's where it's going to be. So by incrementing the top and the left, that's the points where I start drawing the thing, it looks like it falls down. So it's pretty neat that this actually works. Now, we can do a little bit more with this. Okay, let's make a second one. We're going to put in a new one here called Animate 2, and it will be blue. Okay, it's still going to be 50 by 50. And its color will be blue. Okay, and we're going to add this as another div within our container. Okay, so now we have that. We're going to do it. Let's see. We're going to make this one, we're going to give it its new positions. So let's see, set interval. We're going to do this one too. A lot of this we're just going to copy. We're just going to call it my move 2. Okay, we'll do that. We're just going to put a bunch of 2s in here so it can all be very quick. Okay, so this one, we're going to start at 350. We're going to start this blue one in the other place. Okay. What else are we going to do? Let's do its, we'll decrement it 1. Okay, so that'll be 350. Let's do, so we're going to start at the left. So the top will be at 350 here. The left will be 350 minus that. So initially, we will start at 0 and then we'll go up. Okay, so then I got to call that thing. So where's my move? Okay, we'll see if I messed anything up here. All right, I got to run this. It doesn't like that. What's went wrong? I mean, I could do it this way. Oh, position equal clear interval. Oh, because I'm doing the same thing. This is what I want to do. Where's my set interval frame 5? Okay, I'm going to pull this out. Yeah, wasn't quite as elegant as I had hoped. So element2 is that. Okay, we'll just share that variable. Oh yeah, okay. Oh, that's what I was doing. Okay, my bad. I see what the mistake was. Okay, I have to do the LM2 here. That's better, huh? All right. No, it's almost better. Let's see what else I missed. Frame 2. I don't want to use the separate timer. Okay. Okay. Sorry, I got this insert button. Everything's a little off today. Okay, so we're going to do this. We're just going to list LM2. Fine. We're going to bring all this up here. Frame 5. Okay, so that's going to do a 3M minus that. Fine. Let's see how that goes. Oh, I got to run it. There we go. Okay, not exactly as smooth as I had hoped, but we got the things to cross. Now, the neat thing about this, what might not be immediately apparent that this is kind of freaky. Normally, if you're drawing these divs, right, they have to be nested within each other, but they're not. Clearly, they're drawn on top of it, but their coordinates can overlap. So, in a sense, as far as the HTML is concerned, these two objects, yeah, they're both nested within the container. But when they're actually drawn, when they're rendered to the proper coordinates in your browser window, yeah, the individual pixels can totally overlap. So anyway, simple little thing there. Okay, we'll go back to the slides then. Let's see. So what you have fundamentally, you have tags that get referenced by their ID and the style tag in the document head, right? So this is what's up here. In the style tag, we have a bunch of different, things, basically components that we can draw. So what's the container arrangement? Well, you pick one tag to be the container. In our example, we called that container. And then one or more tags can be in the container. So we had two little squares in it, one red, one blue. Now, the easiest way to do this is not the only way, but the easiest way to do this is to give the container a fixed size and give the moving tags an absolute position attribute. So that's what we do here, right? So the container, we give it this height and width and we never change it. These, we set their position to absolute, which means we can specify particular pixel coordinates within this container, right? And it'll be absolute within that container. So if I pick 0, 0, it's going to be up there. If I pick 350, 350, it's going to be down there. Hold on, we got some guys doing yard work. I'm going to close the window here. Hang on. All right. Not going to compete with the lawnmowers this morning. Okay. So that's the container arrangement. Now, the weird thing again, the tag graphics can overlap even though the tags are nested within the HTML. So if you're doing some simple stuff, if you just want to draw some images, traversing a fixed space, yeah, this DOM animation will work pretty well. Last one we're going to talk about, redrawing the canvas. Okay, so thing about this canvas, all that data that's in your canvas tag has to be stored somewhere. And the format that it's stored in is basically a big array with 4 bytes per pixel. So the first 3 bytes are our standard RGB color, right? 0 to 255 for red, same for green, same for blue. The 4th byte is something called an alpha. The alpha is a value used for transparency, that when you draw one thing over the other, it tries to figure out how that should be applied. For example, if you draw something completely transparent over a surface, it's not going to be shown. So, right. But if you do varying degrees, if you draw it like half transparent, then you'll see, you can see some of both what you draw onto the surface and then some of the surface underneath. And this is known as RGBA, so RGB alpha model. So implementation, how we do this? Well, first of all, our context, right, our canvas context attribute has a get image data function. So what that does is it reads all of the, this RGBA data and you can store it into an array. So create an array, pull all this data using getImageData, run through some loop to adjust the pixels for whatever you want to have change, right? Do that. And then last, update the pixel array through the context putImageData function. So again, you've updated this array, and then you send that array to context putImageData, and it just gets redrawn like that. Okay, so I can do a simple example. Actually, I believe I did, didn't I? Didn't I post? I think I posted up something about that last week. Let me look in the code demos here. I spent a few minutes slapping together something. Fade, yeah, okay. Here we go. So this, right, this is a thing that I put together. We'll talk briefly. Okay. So what I do on this one, we'll see what it does first, and then, so I'm going to do draw, boom, and then dim. Oh man, the lights are going out. Okay, so it's not super smooth animation, but it does what it's supposed to do. So the draw, we have two buttons, right? If I look down here, button on click draw, I call a draw method. If I have the dim button, I do the dim button. Well, let's see what's in dim. So, or see what's in draw first. So draw, I'm doing this. This image data is going to be an array, and I'm going to get it from CTX, that's our context, get image data 0, 0, 512, 512. So basically I'm reading the whole thing. This is a 512 pixel square canvas. I'm going to start up here, read everything all the way to the bottom corner. Next thing I'm going to do, so this is the data, right? So var pix is image data.data. So the context has an image data object, right? And then that image data object has its own data attribute. So I have to specifically look at the data. So here, wherever image data.data is stored in memory, pix is going to point to that same point in memory. It's going to have access to this stuff. Then I loop through. So for every one of these pixels, there's going to be 4 bytes. So I start at 0. I continue until I reach the end of pix, right? Until I reach the end of this data batch. And then after I do each action, I'm going to update I by 4. So I'm going to look at the next pixel, which will be 4 bytes down the road. So the first thing I do, I set this I pixel to 0. So that's going to be the first pixel of the first byte of the 4. So it'll be the R of the RGBA. So I set that to 0. There's no red. This one, second one, is going to be the green. And I have a modulo function here that basically accounts for the fact that I'm tracking this stuff in rows. So I want it to display a smooth sequence of color horizontally. Okay, same thing for blue. I do the same thing there. So it's going to be this greenish blue, and it's going to be darker over here, brighter over here, right? So again, when I do draw, there it is. So it's very, close to 0, 0 over here, and close to 255, 255 over here. The last one is going to be the alpha. So I set that to 255. So whatever I draw over, it's going to be opaque. It's going to block whatever was underneath it. And then I send the image data back. So this whole batch of data I have, right, everything that I read from here, from the initial context in the first place, and I've updated it, I'm going to change that back. So image data, right, is going to be all this stuff. When I change things in pix, I also change things in image data. And so when I push that back, I'm just saying, here's the data for the canvas, and it's automatically going to get redrawn by the browser. So that's all that's happening there. Boom. And if I want to, I could make different formats. For example, I could have it be just straight black to white, but this is what I want to do for that. Okay, if I wanted to do that, boom, right? I have that gradation. If I wanted to do purple, right, I could just set the 0 down here, whatever, boom. Whoa, what did I do there? Red and green is yellow. Sorry, I meant, yeah, you know what I meant. Boom, boom. There we have it. So simple stuff like that. Now the other part is the dim function. So down here with the dim, okay, I have, again, same thing. I get the image data. I read it from the context. I store it in this array called pix. And this one I have a max number. So this max is going to determine basically check whether something changed or not. I'll show you in a second. So here I go through the loop, same thing as before, 4 bytes for each pixel. So the first one, I'm going to say I use the max of 0 or the number less 5. So each time through it, I'm going to say, well, if it's not 0, okay, I'm going to decrement the pixel attribute by 5. So gradually everything will proceed to black. Same thing for this. Next one again, I use the math.max, whatever's greater, 0 or that number minus 5, same thing there. And for the alpha, I don't do anything, but I check this. I say if this is greater than 0 or this is greater than 0 or this is greater than 0, then max is 1, and I'm still doing something. Okay, this one, if max does not equal 1, if I make a pass through the image and everything's black, okay, then it says, okay, you're done. I can clear the interval. Now, it's not the only way I could do it, right? Of course, I could say, I know it's not going to be more than, say, 51 times, because even if it's 255, if I subtract, 5 51 times, that'll get me there, 255 down to 0. I could do it that way, but here I'm just reading the pixel attributes. Okay, so same basic structure. Once again, get the image data from some specified rectangle, assign it its data attribute to an array of your own, scan through the array and update whatever pixels you want to update, and then stuff the data back onto your canvas, okay, through the image data attribute. That's it. Okay. So over here, back in the slides, I have an example here, right? So this is just a simple framework one, not the, doesn't actually do much. But if I wanted to, here's my clear canvas, okay? So I have some canvas with width 512, height 512, and I want to just turn it blank white, okay? So get image data is the method I call. So var image data equals ctx dot get image data from 0, 0 with height. So I'm grabbing data from the whole thing. I scan through the pixels. For every one of them, I set red, green, and blue to 255. That's going to make everything white. I use the alpha, so it's all going to be opaque, so it's going to overwrite whatever's there. Then afterwards, I stuff that image data back into the context, back into the canvas. That's it. Okay. Questions on any of these? Makes sense? I mean, at least in principle. You can try them yourself. Okay. So the next thing, let's talk briefly, managing our frame rate. So just, good ideas, pretty much common sense once you've played around with this stuff for a bit. Number one, don't try to pack in too much complexity, right? The more complex your images are, or the more complex the redrawing process is, you may overload your computer, may not work so well. In particular, if you're going to store these images, right, don't try to reload whole bunches of them from remote sources at short intervals. It's not going to work very well. So you'll want to download a batch of image data if you're using, some kind of image flipping technique. Number three, if there's a data structure that isn't being used, you want to get rid of it. So a couple things you can really look out for. Number one, array size creep. If you have a game that perpetually adds on new data to an array, but most of that data is old and not being used, eventually the size of that array will start to eat into your memory, or just the fact that you're scanning through the array for various purposes will take a lot longer. So it's a kind of memory leak. If there's something in your data that you're not using, it should just be done with it. For example, in my Slugfall game that I showed earlier, once I blow up a slug, right, once I bump into one, it goes back up to the top of the screen. Once it reaches the top of the screen, it actually gets removed from the array. So there's not really a memory leak there. And other thing, timers that have served their purpose. So if you don't want to keep endlessly creating new timers and then just let other ones sit, even if they're idle, because timers that aren't being used or timers that are being used but don't actually do anything, those two all eat into your system capacity. So just use the timers that you're using. When you're not using them, I don't know, turn them into some numeric variable or something, but don't have them still run as timers. Last thing, test your code on a low-end machine. See how it handles a busy situation, right? So if you're designing some app for, say, iPhones, try it on an older iPhone, you know, maybe not like an iPhone 2 or something, but something that's a few years old, see if it can handle it. And then you'll know that the new ones can too. All right. Now, that's it for animation. A lot of the principles of animation are certainly applicable to games, but here we'll talk about games more generally. So first thing, games typically have what's called an attract mode. This is, if you've ever been in a video arcade, and I know they're not the draw they were 40 years ago, if you've ever been into a video arcade and you see that there are machines up and running, even if nobody's playing them, their screen is doing some stuff, right? It's going through some portion of the gameplay, or it's flashing lists of high scores, stuff like that. It's called attract mode because the idea is some random person will be walking by and they'll see, oh, that game looks neat. I'll drop, you know, used to be a quarter. Now it's like I'll drop like $5 in it or something. So that's what attract mode is. It's what the game does when somebody's not actually playing it. Now, when you actually start the game, whatever mechanism that requires, once you actually start the game, that's going to launch some loop. Basically, the user is going to do something. There's going to be automated elements in the game that do something. Graphics are going to get updated, and you're going to check if the game ends. And this is true for pretty much every game you can think of. So imagine if we talk about Angry Birds, the user acts, right? The user puts the bird in the slingshot, pulls it back. Once the person lets go of the bird in the slingshot, there's nothing else for the person to do, right? The bird's just going to follow the physics engine, do whatever it needs to do. Those automated elements are all going to act. If the bird hits some pigs, the pigs are going to blow up, or the buildings are going to crumble, whatever. And we'll see all those graphics update. And then at the end, it checks, did you get all the pigs? Well, if you got them all, then the game's over. If not, you know, maybe you got another bird. Or if you're out of birds, then the game's over that way. Okay, so this is the typical kind of loop that you always see. And they may happen at short intervals, may happen at longer intervals, but the structure's there. Okay. Now, how do you get to launch your game when the page loads? Well, a lot of tags, they're like set of 7 tags last I checked. They have this onload attribute, which lets you call a JavaScript function when the tag loads. So for example, in the body of your HTML document, you can set this onload attribute to be my function. And then as soon as the body loads, which will always do when you load the HTML document, then it's automatically going to go to that my function function. So if you're interested in looking at that, here's a list, right? The onload attribute. You can use it with things like body, with iframes. Iframes are tags for third-party content, images or inputs, links, scripts, styles. So quite a few things you can do that with. And if take a peek at the code for my slug fall in a second, you can see that I actually do that. Where's my falling slugs? Well, that's not the one. It's in download. Slug fall. Okay, so if I open this in Notepad, you can see right there, where's the body? There it is, onload clear canvas. So the first thing it does is it draws the canvas for the base style of the game. Okay. So that's something that is certainly useful. All right. So to implement this, use an onload attribute in your HTML document's body tag, automatically launches attract mode as soon as the page fires up. And then button tags or the canvas tag, when somebody clicks on those, you can allow starting the game. Okay. Next thing, screen object collisions, right? So very, very often, you're going to want your game to recognize when one object clunks into each other, right? If you're, whatever you're doing, it's going to be potentially significant. Now, there's a couple ways to do this. Number one, mathematical. So if your shapes are fairly simple polygons, this is an easy one to do. You can check whether an object's edge overlaps with another object's edge. And if they do, then you're going to say, oh yeah, those things, they bumped. Okay, so for example, suppose I have this square here, right? This is square one. I'll do another one. Let's make, I don't know, you can be blue, I guess. I have another square. Okay. If this one, if it bumps into it like that, I could say, oh man, something bad happened, right? And how do you know? Well, here's the thing. There's a little bit of this in the W3 Schools game, but basically, if the top, I'll go through the first one. if blue top is greater than black bottom, okay, then there's no contact, right? Likewise, if blue left, right, if the left edge of blue is greater than black right, again, no contact. So you do these 4 cases, right? You see, is this thing to the right of it? Is it above it? Is it to the left of it? Is it below it? In the case that these are both squares, okay, and so on. In the case that these are all squares, then if you've covered those 4 cases, then you know that they can't possibly be overlapping. So with squares, it's not too bad. With circles, right, similar thing. I can just check for the radiuses. So if this is the center here, or whatever, if the distance between 2 circles, right? So I can say, okay, distance, let's do that in bold. Distance equals black x minus blue x squared plus black y minus blue y squared, right? This is our difference, you know, this is just our difference, our distance between the centers of the 2 circles. And I can say if distance is less than radius squared, then no contact, right? So if this, figure out this distance, and this is going to be the squared, right? So the distance would actually be squared. If I wanted to get this, I would have to take the square root. But the distance squared is this, and if that's less than the radius squared, then there's no contact. It's easy to understand. So depending on what kind of polygons you're using, you could check for, you know, spatial overlaps. You could check if their radiuses are close enough, things like that. The other option, if you're dealing with non-polygon shapes, or if you're dealing with somewhat more complicated ones, you can do it pixel-based. So basically, whenever an object moves, you can check whether its leading edge overwrites any pixels in the other surface. So for example, right, suppose I have something like, suppose I have some lava down at the bottom. We're going to draw some lava here. If I can. Get up there, you. I don't know. So we got some lava down here at the bottom. Okay, and if anybody steps in the lava, I didn't think I got it all. Okay, fine. Just gonna do it this way. Boom. If anybody steps in the lava, well, you know what happens, right? Boom. They get lavafied. So what I can do, if we have some little stick figure guy that I'm drawing, and he's falling, and we're hoping he doesn't fall in the lava, but, you know, he probably will. He's going, ah. So every time this guy is drawing down, I could check his leading edge, right, which would be something along the lines of like here. I can check, you know, these surfaces or these surfaces or this surface, because if these are touching lava, then, you know, something else is. And every time I rewrite those pixels, I just look at where they're being rewritten. And if I say, okay, the next pixel that I'm about to write with one of these is red, then, he hit the lava and it's all over. Okay. So you can do that, okay? But then you got to map out your images, and you have to account for the fact that this guy may be in motion, right? His arms and legs may be flailing while he's in the air. But yeah, however that image is, you have some other kind of data that says, here's the leading edge at that point in the animation, and you check and you see if he falls in one of these red lava pieces. Okay. So there's that. Okay. So that's some basic stuff. I will add, there's no shame in borrowing non-proprietary code, right? You don't need to reinvent the wheel for everything you do, especially for stuff like graphics. If you want to get decent graphics, you could, if you're not a professional, you could spend all day trying to code up this stuff and put things together. It's still never going to really look good. So yeah, go ahead, borrow standard packages from other things. And same applies to standard code. If there's some element of drawing graphics that you don't get, and you can find a standard generic example somewhere online, yeah, of course, why wouldn't you use that? But I will add, try to understand what you borrow, right? So you're not just grabbing random pieces and slapping them together with no idea of what you're doing. Because if something doesn't work the way you think it should, then it's going to be a lot harder to fix that. Now, depending on your interest, if you decide, hey, this game design thing sounds kind of fun, maybe I'll give it a try, you might be interested in graphics packages, physics engines, stuff like that. There are a lot of code libraries out there. Some of them are even free. So for example, javascripting.com has a long list of helpful things. Okay, so all sorts of stuff for animation, stuff for games. Yeah, so you could see all kinds of neat stuff in there if you want to take the time to browse through it. Okay, now the other thing though, if you get some of these code packages, these code libraries, and they are free, sometimes they are part of an open source licensing project. So if it's open source, it's going to be free for you to use, but it will also mean you can't use it and sell it. Okay, so if you build your program with these open source tools, then you will not be legally able to bundle up your program and sell it. So, and if you try, you'll probably get caught. You can still put the animations on your website, right? You can put the games on your website and have people come and maybe get them to click on ads or something while they're there. Sure, that's legal, but you can't charge them for the game itself. Okay. So there's that. So if you're interested, again, look around. I'm not really a full-time JavaScript guy, so I haven't done much with this, but yeah, there's tools out there, lots of stuff out there. Second thing, coding graphics effectively, right? If you're not just doing some really basic stuff, you can require a fairly deep knowledge of JavaScript and all of its quirks. So what you'll often see, the syntax can be correct, but the code might not do what you think it should do, right? So all the pieces are there, it's not getting any errors, the code's running, it's just not doing what you think it should because there's some weird hidden wrinkle in the code that you just don't know about. Also, you can have code that's totally correct, but performs badly. So for example, one of the common novice mistakes is when you call graphics updates in methods called by events. All right, so we have, for example, here, let's do this. Let's find our W3 Schools game. Sorry, I gotta drop all these. Okay. Okay. So if we have this, let's go to try it now. Down here, this is the, where's our interval? Every interval. Every interval is, I believe, the piece that the function that gets called. Where's my set interval? Oh, the other, no, it's this update game area. So update game area gets called all the time, and there's things that it's looking for. It's looking for this accelerate. Now, if I were doing some mouse motion in here, the problem is this: the system is going to be checking for mouse motion, maybe 30 times a second. So all the time it's going to be checking for mouse motion because that's something that happens at the level of the operating system. It's designed to give very fast response. If in that same function I draw the graphics, then it's going to eat up a lot of time trying to keep up with the graphics at that speed, which you basically can't. Instead, what you want to do is set up some interval timer, right, where somebody every now and then the graphics get refreshed, like every 10 or 20 milliseconds. You check and see, does anything need to be refreshed? I'm going to refresh it with the current state of the game at that time. But if you put it in the same method that gets called whenever the mouse gets checked, if there's like for mouse motion, then that function is going to get called way too often and the graphics are going to be slow and choppy. So Okay. Anyway, my key takeaway from this, don't spend all day trying to fix a problem that you might never find. If it's something that's a quirk in the JavaScript language, something that's not a syntactic problem, something that, oh, I had no idea that, trying to draw graphics in the same function where I'm checking for mouse motion would be a problem. That's not something you're going to ever find by ordinary debugging. So if there's a problem and it doesn't seem to make a lot of sense, try something else. So some good resources. Number one, stackoverflow.com. Stack Overflow is your friend. The wonderful thing is, if you have a question, probably somebody else has already asked it. Probably several other people have already asked it. And there are blogs, so if you do some kind of Google search for a particular problem, like why aren't my JavaScript graphics refreshing quickly, you'd be a little bit more specific than that. Yeah, some of the stuff is going to be Stack Overflow. Some of it is going to be specific blogs from JavaScript coders. They might have insights too. I don't have any specific recommendations for blogs that like this is the blog you want to go to, but just be aware when you're getting these Google search results, a lot of them are gonna, that don't turn you to Stack Overflow, are gonna turn you to blogs. Okay, so a couple things, good practices. Number one, floating point math in particular can cause inconsistencies in drawing. So if you're, for example, drawing a circle, inevitably drawing the boundary of the circle is going to involve some floating point math. And so when you try to overwrite it, you should always allow an extra pixel. So, you have your old circle. First, you draw over the old one to make it clear. Then you draw the new one in a new location. If you do the exact same pixels with the exact same radius, there can be enough variation in the floating point numbers that sometimes you'll see, yeah, it didn't hit the exact same pixels the exact way. There can be like little shadows of pixels that persist. Okay, don't draw graphics in the same method that reads mouse events or other events. Yeah, because those get checked for at very short intervals. It's going to make your graphics choppy. If you have a set of frequently used data, maybe you don't need to grab that for every time you pull the method, right? So if you're doing some simple stuff like my Slugfall game, yeah, okay, you can do that, over and over. But if you're doing more advanced stuff, basically you want to store this map of your canvas and access it directly. You don't want to have to keep obtaining it and pushing it over and over. You want to have it already sitting there and you just alter what is there. Last, don't set overly short intervals, right? Don't do something crazy like try to do a bunch of graphics and then have like a 1 millisecond refresh interval. That can cause your graphics to be very erratic. And really anything faster than 25 milliseconds, which corresponds to 40 frames per second, probably not going to be noticed by humans. So typical upper limit of what humans can notice is something like 25, 30 frames a second. Anything more than that, yeah, it's going to look smooth, but the humans aren't really going to notice the difference, and you may be putting load on your machine and having it be a little too choppy when the game gets busy. Okay. Now, understanding code written by someone else. So until you've actually worked in a coding team or in some kind of group setting, it's really hard to appreciate how important it is to document your code well, right? So if you write some program, you're looking at it, you know what you wrote, you know how it works. Yeah, you might document some basic stuff. So if you come back to it in a year, you won't have to spend a whole lot of time thinking about it. But there's all sorts of oddball things that happen, right? Standard, you have your set of default variable names, could be different for somebody else. You knew what you were doing when you were coding up some algorithm, somebody else doesn't. Stuff like that, it could be can really slow things down in a group setting. Now, a lot of the available code you'll find online is minimally documented. So it means you got to trace through it. You got to identify the starting point. You got to identify the data elements, trace out the code flow. And that can be a challenge as things get complicated. So this is actually a very strong argument for writing modular code where you don't have it all in one big slug of text. Instead, you have little modules. Each of it does a particular thing. To some extent, you get that inherently in JavaScript with functions, but if you could take the pieces apart and then, in a sense, almost have them operate as separate programs, it makes it much more easy to understand, right? You can build a library of these kind of modules. Okay. So what we're going to do, we're going to take a minute, we're going to pick apart the Flappy clone game. Okay, now our Flappy clone game, let's pop into the graphics here. Okay, that's what this is. This is the Flappy clone. It has a few things, so we can start it. Let's go. It has the attract mode. It just kind of sits there when nothing's going on. It has gameplay. There's gravity. It has the objects, these green bars, and me, the red block. It has a timer that goes on. It has another object for the score. Oh, if I break 1,000, then I win in my own mind. Yay, I win. And now I die. Okay. So it has all these basic video game elements, but let's trace through them a little bit. Okay. So I'm going to do that. I am going to trace through all this. I'm going to put it in Notepad here so I can make it a little bigger. And we'll pull that down. Okay. So starting off, here's our document, blah, 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 blah. There's a canvas style. Okay. There's a head. Oh, there's the body. Okay, start game. Great. That's where I start. So as soon as the page loads, I'm going to go to this start game method. Well, what happens in start game? Okay. I'll just put the, okay. Looks like I'm creating the game pieces. Game pieces, setting, initial, parameters, right? So here's my game piece. It's some component. Okay, I can figure out what that is. Here's the gravity value. Well, that's going to be what's pulling me down. So the default is 0.05. Here's my score. Oh, that's another component. Okay. And then start my game area. So here, I'm just calling a couple constructor methods. I'm creating a new thing. Here, I'm creating a new thing. Here, I'm setting an initial parameter. Okay. But this, game area start, this appears to be where the execution flow starts. So let's go check that out. Let's find this start. Here it is, game area.start. Oh, there's game area. Okay, start. What happens? Aha. So set the canvas width. Okay, so build the canvas. That makes sense. Okay, and here I'm going to construct the object. We have this canvas.getContext2D, and oh, there's the dog. 1 second. All right, dog, get in here. I didn't even know you were out there. Okay. He sees a dog. He has a meltdown. Okay. Fine. Okay, so we create this element, canvas, and then we build it. Okay, and we insert it into our body document, so it's going to be the first node in there, the first, object in our HTML document. And this, we're not sure what this is. This dot frame number is 0, but we'll see. 1 second, dog. You gotta settle down. All right. So we'll see. This means no bars crossed yet. This will make more sense in the game flow. Okay, and then this last thing, we're going to create a timer. 20 millisecond timer to call update game area. Okay, so that's what this is. When we say set interval, update game area 20, that means at 20 millisecond intervals, we're calling update game area. And there doesn't seem to be anything else going on. All right, we have a question here. You're going to, yes, I will upload this HTML to Blackboard. Although it's already there, but I'll upload the documented stuff, yes. Okay. So we see this is the game area, and that's what we're calling update game area. So let's scroll down, we're gonna find that. Okay, here's update game area. Now this is a little weird to look at, but what I'll tell you is this, having gone through it a bit. My obstacles is an array of the green bars. Okay, so every one of those green bars that happens, it gets stored in this array. And for each one of them, for each bar, each green bar, check for collision. We'll go back and look at that in a bit, but this crash with, that's going to see, oh, did my game piece crash with one of these obstacles? So you're going to check for each of them. Okay, otherwise, clear the game area, fine, and we're going to draw it. Okay, so we add, and it, for the game start, we add a frame. Okay, we add a frame number. We say this, if my game area dot frame number equals 1 or every interval 150, we'll see what that is. Then we're going to add on a new one. Okay, so if the frame number is 1 or it's been an interval of 150 milliseconds, add a new green bar. Okay, add a new obstacle. So if we go down here and see every interval, that's what this is. It just checks by modulo. If the frame number divided by n modulo 1 equals 0, right? If it's an even number of 150, then that's going to return true. Otherwise, return false. Okay, so again, every interval 150, every 150 milliseconds, it's going to add on a new green bar. So what it's going to do in here, specify the bar. Okay, so it's going to give it a height, it's going to give it a gap, it's going to locate it at the edge of the canvas. So the new bar is going to, its initial X attribute is going to be at the far right of the canvas area. Okay, and then it's going to get added to the array. Okay, so add, or I'll say append, new green bar to the obstacle array. Okay, and it's going to add that bar. So first it's going to do the top part, and then it's going to do the bottom part because there's going to be a gap. Okay, then for each one of these, we're going to do an update. So for each obstacle, do an update, right? Which for one includes moving it to the left. Move it to the left 1 pixel. That's decrement its X attribute. Okay, and then we update. So what is this update going to do? We'll look at that in a second. So we update it, we show it in its new position on the screen. Same thing with my score. The my score is going to be the frame number, so it tracks how far we've gone. And then we update it. So let's look. Let's see what update does, see if we can find that. Update, update, update. Aha, there it is. So update is just going to draw it. Okay. Update function draws the new component. Because remember, we've already cleared the window when we do this. That's right. That's the first thing in the update game area. We clear the window. So then we draw the new stuff on top of that cleared window. Okay, and I do the same thing again with the score. Game piece.new POS, so new position. Okay, so here I'll do a thing. Update game score. And here, update player component position. Okay, so my game piece, new POS. Let's see where that takes us. There we go. Okay, so for new position, basically it does this. Okay, number one, okay, so this is going to update the XY coordinates based on current gravity. Okay, so first of all, the gravity speed is going to get updated by whatever the update I've made is, and we'll see that in a second. This X is always going to be speed X. So whatever the current X attribute is, basically increase X by speed. X speed is unchanging, right? It's constant. Let's just say constant. Okay. And then the Y, I'm going to update it on the basis of speed Y plus gravity speed, right? Because gravity accelerates. Increase Y by current Y speed plus gravity effects. Okay, and that's it. And if I hit the bottom, I'm checking to see if I hit the bottom. If I do hit the bottom, then I'm going to say gravity speed is 0, right? I just sit there at the bottom, I stop. That's it. And if I'm not, then I don't have to worry about it. So I can make this if you hit the bottom, gravity speed becomes 0. No more downward motion. Okay, so that's that. Now, last thing, right? We can look at the buttons here. So the buttons on mouse down is accelerate. That means minus 0.2. So remember, smaller numbers mean I'm going up, right? The 0 row is at the top. The 0 y coordinate is at the top of the window, top of the canvas. The higher numbers are down towards the bottom. So if I'm pressing the button on mouse down, I'm reducing the acceleration. If I'm doing on mouse up, once I let it go, it goes back to 0.5. So whatever the gravity is at that point, okay, that's the new amount that I added to it. So if the accelerate is 0.2, yeah, negative 0.2, it's going to go up a little bit. It's going to float a little bit. Because up here in my math, when I say gravity speed plus equals this dot gravity, so I'm going to reduce the gravity speed by 0.2. On the other hand, as soon as I let it go, the gravity speed is going to increase by 0.5 with every cycle. So with every update in the frame number, it's going to sink faster and faster. So I got to kind of balance it out. Yes. Randomize. Yeah, you can randomize everything. Yes. Okay, so you had a question, can you randomize stuff, range of seconds? Yeah. For example, right, if I wanted to do a bar, for example, suppose I wanted to have the next bar not be 150, but if I wanted to have it be a random number, a rather large random number, let's see, how would I do that? Frame is 1 or every interval equals, well, I could just do like a get next interval. Okay, so instead of every interval 150, I could do next interval. Function next interval. Okay, but I need to create a new var for that. Let's keep it here. Var ni for next interval. That way I at least know it's not used. And I'll have the first one be 150. Okay, so every time I hit next interval, I could decrement if, let's see, ni minus minus, if next interval is equals 0, return true. Okay, else return false. Let's do this. I'll even this is a simple change to make, so I can do this. I'll do the next interval. Ni equals what? Let's do math.floor. Floor is like the lowest integer above something. So do math dot random times 101 plus 100. Okay, so here I'll be getting a random number from 100 to 200. Okay, I could do that. So in this, where's my this? Or, okay, let's, instead of every interval, I'll do next interval or next interval. Okay, we'll see if I mess something up here, but that's the idea of what you would want to do. Okay, so you see the bars should be at different intervals, not all regular. Yeah, you can see now they're at different, they're variable. Okay, So you can do this stuff. You can tweak things. If it can be coded, it can be done. Yay, got 1,000. Now I win. Okay, good. So yeah, we can make some simple changes. Okay, so here I'll just mark this. I'm going to code this in here in my notepad. Die in lava. Where's my notepad? Okay. So this one I'm going to say every interval. So fixed interval duration. And over here I will have random interval duration. Okay. So that's it. Works. Anyway, so the takeaway from this, if there is code, somebody else has written it, you might have to dig around in there and try to figure out what all they've done. You might not immediately figure out everything because, for example, this gravity thing might take you a second, or this here, this crash with function, this here, this is the line that says, checks all the 4 cases of the square boundaries bumping in against each other. Yeah, that's not the sort of thing that you're going to walk into this program and instantly know that that is going to work. And you can see what it's trying to do, but you're not going to instantly understand that that's exactly how it works and that it's automatically going to cover all the cases. You got to think about it for a second. That's okay. All right. But mostly you can figure out the flow of the program, and you can certainly figure out enough to say, oh, I want to do this thing different. I can change the gaps between the bars, or I could change the height of them, or I could change the size of the gap, right? Min gap, max gap, that's pretty easy. If I wanted to change the size of the playing piece, for example, I could look in the details here and say, this new component. Well, the first 2 things are width and height. That's tough to misunderstand. Likewise, if instead of color, maybe instead of red, I want it to be blue. Okay, you could do that. Okay. So stuff like that, simple changes you can make, and you can understand how the program works. Okay. So I think that'll do for now. I'm going to stop recording.